Hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily challenge of making a large Iceland, and this problem is similar to a number of Iceland problem, and this is a hard level problem. And in this problem, we have to given a n cross n binary matrix of grid, and binary matrix is 0, 1, and you are allowed to change at most 1 0 to be 1 and return the size of the largest Iceland in a grid after applying this operation. And an Iceland is a 4-directionally connected group of ones, and now we have to given a example test cases, and then these are our constraint. And now let's look at their problem statement, then we have to jump on their example test cases so that we have to a better understanding how actually we have to uh, done this problem. So in this problem we have to given n cross n binary matrix 0, 1 matrix, and also our we have to convert at most 0 into 1 and find the size of the largest Iceland that can be formed after this change. Like we have to change 0 to 1 at least one time, and our goal is we have to identify all distinct Iceland in the initial grid initially where we have to 0, 0, okay, and then find the size of the largest Iceland, and then we have to try to changing each 0 into 1, and then we have to calculate new Iceland, and also we have to return the maximum possible Iceland size after performing at most one conversion, like 0 to 1 conversion is at most one time. Then we have to find their maximum Iceland, okay, maximum possible Iceland. And now let's look at their constraint, so that we have to look their algorithm efficiency. And here we have to given n is equal to grid dot length, and the same thing for this one, and this is our square grid. And also we have there 1 less than is equal to n less than is equal to 500, and this is the maximum size can be formed as 500 into 500, and this become 250, and these are our cells, and this grid of ij is either 0 or 1. And the algorithm is basically we have to use since n can be large up to 500 into 500, and a brute force approach after checking every possible 0 and 1, and this separately is inefficient. And then efficient approach is basically we have to use BFS, DFS, and union find, you can say union find, and the find distinct Iceland and store their sizes by using these algorithms. And we have to change when we have to change 0 to 1, quickly sum up the size of their adjacent Iceland. Like if we have to update this one, we have to calculate this size, and this size, and so that we cannot pre-compute again and again, because we have already pre-compute the value, okay. And now let's look at their example test cases so that you can understand how actually we have to work with their values and their grid. And so now this is our first example, and the grid is and here 1 0 and 0 and 1. And now label of Iceland by using DFS we have to calculate here, and start from our DFS 0, 0, and this is our starting node, and this is our ending node of 1, 1, okay, and this is our start. And now the label this Iceland is, this is our label and this is our label, okay. And now here we have to calculate the Icelands, okay. And now when we have to make this as a label, then this is becomes 2 and this becomes 3 because of this is the last one. Like you can say sorry, this becomes 0 2 0 0 3. Okay, and then the Iceland size of this one is, and this Iceland of 2 is become size of 1, and this Iceland of 3 is size becomes 1. Okay, and then we have to change the value of 0 comma 1 to 1. Okay, and then connects the Iceland of 2 with the size of 1, and the same for this 2 is size for 1 and this 3 is size for 1. Okay, and then a new Iceland we have to become. So new Iceland is what? So the new Iceland is, let's suppose this one. Okay, we have to change this 0 into 1. We have also discussed here, like at most one value we have to change. Okay, so here we have to calculate this one become 1, and so the new Iceland size is 1 plus 1 plus 1 is equal to 3. Okay, and then we have to change this, you can say this one we have to change, and you can change also this one, but this remains 0 as same. And now here we have to change this one, so that's become 3, and now we have to change same for this 1 comma 0, and this 0 comma 1 we already changed. And now 1 comma 0 we have to change also, connects with Iceland 2 with size 1 and Iceland 3 with size 1, and new Iceland size is, if we become 1 here, and then it becomes 1 plus 1 plus 1 is equal to 3. Okay, and now we have to find the maximum. The maximum of this one is 3 comma 3 is equal to 3. So answer is 3. And now let's look at their example second. So in this example we have to given 1 1 1 and 1 0. Now 1 1 and 1 0. So now we have to make all labels, and this becomes 2, this becomes 2, this becomes 2. Okay, and these are our labels, and these labels are like all one being a same Iceland. So that's why we have to that's why we have rated as 2. Okay, Mm, because of if 1 plus 1 is 2, and same thing for 1 plus 1 is 2, and so that's why. And here 3 is basically for if we have here is 1. Okay, here is 1, let's suppose 1 plus 1 is 2, and then you can say this become also be 2, and 2 plus 1 is 3. So that's why we have to use here 3 and here 2 and here 0 and 0. Okay, I hope you understand this one, why we have to use this 2 and 3. And now this one, this becomes 2 2 2 and 0. Okay, and now the Iceland size of 2, the Iceland of 2 with size 3, because this 3 sizes we have to also given there. And now the step 2 is we have to changing 0 to 1, and 0 to 1 we have to change this 1 comma 1, and this 1 comma 1 we have to change after this. It connects with Iceland 2 also. So the Iceland 2 with size 3, and the new Iceland is become these things are 1 plus 1 plus 1 is equal to 3. So total is, after changing this one, after changing this one, this become 1, and so 3 plus 1 is equal to 4. Yeah, 3 plus 1 is equal to 4. So now let's look at their example 3. 1 plus 1. Okay, so here and no any 0, and also we have to given here at most 0 converts into 1. So here no any 0 is present here, so that's why the answer of this one is 1 plus 1 plus 1 plus 1 is equal to 4, and so this becomes 4. So now let's look at their one more example test case, so that you can understand how we work with their elements. Now let's look at their a bigger example. And so here 1 1 0 and 1 0 1 0 1 1. Okay, so this is our example. So we have to start from 0 comma 0, and we have to traverse with their DFS call. And now 0 and 0 is labeled with 2. Now this becomes 2, and also this also becomes 2, and all this one becomes 2, and this becomes 3. Okay, when we have to change this one, okay, this one, so that's why we have to here 2, and if we change this one, and so 2 plus 1 is 3, and 3 plus 1 is 4, and this, and if we have to change this one, 2 plus 3, and this becomes 4. And now after labeling our grid, what we have to get here, we have to get 2 2 0 and 2 1 3 and 0 4 and 4. And now the Iceland size is Iceland 2 size is 3, and 1 2 3, and this 3 size, this becomes 0, and this 3 size is 1, and this 4 size is 2 after label. Okay, and now we have to changing each 0 to 1, and now then we have to calculate. First we have this 0 comma 2. After 0 comma 2, our Iceland will become Iceland of 2, this Iceland of 2 of size 3, Iceland of 2. Okay, these two with size of 3, and Iceland 3 with size of 1, because this is connected with this one. Okay, so that's why we have to take the size of 2 with the size of 3, and 3 with size of 1. And now new Iceland is become the maximum Iceland, you can say. If here is 3 plus 1 plus 1. Okay, 2 1, yeah, 3 plus 1 plus 1. Okay, yeah, and after this we have our size is 5, and the same thing for now this is for 0 comma 2, and now the second one is 1 comma 1, to change with 1, this 1 comma 1. And now the Iceland of 2 with size 3, Iceland of 3 with size 1, and Iceland 4 is size of 2, because this is closed with this one. Okay, so now this becomes the Iceland of this one is we have the size 3 plus 1 plus 2 plus 1 is becomes 7, 3 plus 1 plus 2 plus 1. Okay, yeah, and now we have to change this one, this 2 comma 0, and this 2 comma 0 is we have to convert 0 to 1. And now this is connected with 2 and 4, this one, and this 2 comma 4, and this 2 with size of 3, and this 4 with size of 2, and now this 3 plus 2 plus 1 is equal to 6. I hope you understand how actually we have to, like, here we have to do these all positions we have to take 3 plus 1 plus 2, and then we have to update with this one, so that's become 7. And now same thing for here, 3 plus 1 is same, and this one is here, so that's why this is 5. And now what we have to find the maximum. So maximum of this 0 comma 1, sorry, 0 comma 2 and 1 comma 1, and this 2 comma 0. And now this 0 comma 2 becomes 5, this 7, and this one is 6. And after max this one will be 7. So answer of this one is 7. Okay, so now let's look at their problem statement code, and like how we actually work on their code and their implementation part. And now here first we use DFS, and this DFS we have to search with their label of Iceland. And now here grid of xy is equal to check, and this one will be marked as current cell with a unique Iceland number. And then we have to explore with all 4 direction, and after all 4 direction we have to valid next cell, we have to check with valid next cell. And now here we have their 4 directions, 4 direction movement. Okay, and then this Iceland we have to starting from the number of 2 become, because here also I also be mentioned here, like we also change with 1 to 2, because we have to give in all the labels with their current node. And now we have their this is okay, this one step 1, this is our step 1 for label of Iceland. Okay, Iceland uniquely for DFS. And this one is basically for iterate all the labels, and then this grid of ij is one is found unmarked, and then we have to call their DFS, and then we have to increase their Iceland label. And now the second step we have to here is, this is our step 2. We have to store the size of each Iceland. After storing each Iceland, we have their count of size of each Iceland. Okay, then here is answer, and here we have to find the largest existing Iceland, largest. And here also we have their find their maximum of this one, and then we have to iterate. After iteration we have their first we have their, this is our step 4. This step we have to try to change each 0 to 1, and then we have to calculate the new Iceland size. Okay, we have to change 0 to 1, and new Iceland we have to calculate here. And then this condition we have to found a possible location to change, and after this we have to collect connected Iceland. And after connected Iceland we have insert into our set, and this is our the valid condition, and this is the boundary condition, you can say. And then we have to base our size after conversion, and we have to find their maximum of this one. Like if we getting the maximum, like we have to adding all the values with their maxi, and this maxi with we have to calculate their maximum value, like we have to sum up with their connected Iceland, and this connected Iceland we have to update their maximum possible size here, maximum possible size. And I hope you understand how actually we have to work. In first step we have to iterate with their DFS, then we have to label with their values, and like label means we have to change this one, this form. Okay, and then we have their step 3 to count all over the grid, and then here we have to calculate their possible size and possible location to change, and then we have to insert into our set. And now let's look at their time and space complexity. The time complexity of this code is, first we have to use a DFS for labeling. DFS call is uh, O of n square. Okay, and the storing the Iceland size, the same thing for here, O of n square, and the O of n square for checking for convert 0 to 1 after labeling. Okay, so the total time complexity of this code is O of n square plus n square plus n square, and this become O of 3 of n square, so this become O of n square. Okay, so this is our time complexity. So now let's look at their space complexity. The space complexity of this code is O of n square, and this is the modified grid, and the O of n square is storing the Iceland size, and the O of n square is tracking the visited Iceland. This is modify, and this is storing Iceland, and this is visited. So the space complexity of this code is O of n square. The key idea of use DFS of labels with unique sizes, like we have to optimize instead of brute force by changing 0 and 1, then which we have to go with each label and again each label, and we cannot pre-compute all these values, and then we have to find this solution of DFS, because this is the n is less than is equal to 500 solution, and so that we have to use DFS for this one. So I hope you understand how actually we have to dry run this solution and their example test cases, and how we calculate this modify table, like this 2. First we have to 2, then we have adding with another values. Okay, and so thank you everyone, thank you so much.